I, in function notation, call your answer f inverse of x. So when I come up here where I'm at on step 4, I'm not doing anything except renaming the y with fancier notation, and I still have x squared plus 4. And finally, I need the domain and the range of my inverse function. Okay, so the graph, which I just erased, but it was like this, right? That's the one you have on your paper? Yes? To find an inverse graphically, I think we talked about this yesterday, I put the line here at y equals x, and I would flip this over that line. If I just have x squared plus 4, that would be this entire parabola, right? Which is not a reflection of what I have right here. Which is why the domain and range discussion is so important. I'm actually only interested in the right half of that parabola. That's the only thing that would be mirror reflected if I took this guy and flipped it over. And the good news is, at the very beginning here, we decided the domain of this graph was 4 infinity, and the range was 0 infinity. And I told you yesterday, if you remember nothing else, remember this. So great news. If I need the domain and range of my inverse, I'm going to take these domain and range values that I got and switch them. So the domain of my inverse function is 0 to infinity. And I think I can confirm that on my picture. Starts at 0, goes all the way to infinity. And the range is 4 to infinity. We trade everything. Give you a chance to finish this up, and we're going to try a couple more. But there's another really nice model on the back on 76. Before we go there, I want you to get some practice without me. So hop up to 77. You don't actually have to hop, but flip to page 77. And I'd like for you to try A, okay? Just A. As a support right now, I'm going to show you what that graph looks like, all right? In a minute, we'll use calculators to help us, but right now, for the sake of time, what you need to know is that negative 16 plus x cubed looks something like this. All right, so let's anchor ourselves in that picture. You can sketch that on 77, yeah. Rough sketch. I don't really know where it's crossing, but I know that that's the shape. So I want you to start with step 1, where you're looking at that picture and asking yourself how many times a horizontal line would touch that graph, no matter where I put it. And then drawing the conclusion, is this 1-to-1 or not 1-to-1? Okay? Keep going. Let's see how far we can get on this one. Use the model we just did to help if you ever feel stuck.
So you put it here? But it really doesn't matter because it's a negative 16, so it would be like all the way down here. So it's just like a rough sketch.
Now, after that, Deja, I need a domain.
To help you. For these type, it wouldn't matter if we did, if we, like, let's say we didn't have a picture.
would it matter if we like, you know how for this one, you told us that we set it equal to more than or equal to 0? But since this one is a cubic one, and it goes like that, isn't it all real numbers?
Cubics are great. Quadratics are great. Every time.
So far, so good. Keep Oh, you don't have any.
Thank you.
Are you done?
No.
Twice. So after you do that, because you go like this to see if it passes the test and it passes, right? So now you're gonna have to, step 2 is switch the variables to get the inverse function. So you're gonna write the equation out, negative 16 plus x cubed, and set it equal to y, and then switch the variables.
Would this be correct?
Like this, look, you write it out like that,
And now just take the y out.
and then you're gonna replace this x with y, this y with x,
Not
and
stopping
this
and
x
domain
with y.
range. Make sure you keep going all 5 steps. Carla, you're great. Now just start isolating your life.
Okay, so now you're gonna change the y to x. So you're gonna write x equals, then negative 16 plus y cubed. You're switching the places of variables. And now you solve. So, right, to get rid of the cubed, you have to cube the x. Or what
I
do
gotta
you
get rid of the 16 first.
Oh,
We're
so I
going
did
to
it
work
wrong.
from the outside in, so the thing that's furthest away.
Good thing I
Cancel
didn't
first.
tell her.
I know. So minus 16. How am I gonna cancel that? You got it. Go for it. You got it. Whatever you do to the left, you gotta do to the right, and vice versa. Not fair if you only do it to one. Careful. This should be 16 plus. Or x plus 16, either way. Equals what's left here. Okay, good. And now the major thing you need to try and figure out is how to cancel a cube.
Out of 1 over, and then that? No?
If it were a square, how do you cancel squares?
Cube it. You cube the other square. Do you cube it? No? You cube root? You cube root, right?
Because it's okay. Let's say if this was a square, you were like, yeah.
Find the square root.
Yeah. So all you're gonna do is put square root over the power of 3.
That's what I was saying. Cube root.
That's square root.
I was talking about the little 3 with the radical.
Because cube is x this, so the one you were gonna do is this one.
No.
With the power of 3.
Yeah.
That's why.